Today we're going to be going over a quick revision question which is going to be highlighting a really important concept in physics, and these are these two types of graphs. One is a force against time graph, the other one is a force against distance graph. Now my question to you guys is, what quantity is represented by the area underneath each graph? So what I want you to do, guys, now is just pause this video and just write down what quantity is represented by the first graph, by the area underneath the first graph, and what quantity is represented by the area underneath the second graph. Now, in order to answer the first question, we need to remind ourselves of Newton's second law. Remember, this says that the net force acting on an object is proportional to the rate of change of momentum. So we can write this as F is equal to delta P, the change of momentum, divided by delta T. Now let's rearrange for the change of momentum. So what we're going to get is that F multiplied by the time that's elapsed, delta T, will be equal to the change of momentum. This quantity on the left hand side is called impulse, and the area underneath an F against T graph is given by the impulse, and the impulse is equal to the change of momentum. So there are two possible answers that we can accept for this question. So I'm going to write impulse is one option. The other one is the change in momentum. I'm just going to underline change because this is a really important word. So either of those quantities, so either impulse or the change of momentum. Okay, now let's focus on the second graph. In order to get the area of the second graph, we need to multiply the force by a distance. Anytime we're multiplying a force times distance, we're going to get units of work done, because work done is equal to force multiplied by distance. Therefore, the area underneath an F against distance graph is equal to the work done. There are many different situations in A-level physics where you're going to get this F against distance graph. For instance, in materials, it might be the force that's acting on a spring, and X might be the extension. In gravitation, it might be the gravitational force against the distance from the center of gravity, for instance. And in each case, the area underneath a force against distance graph is work done. Okay, folks, well, hopefully you found this quick video and this quick exam tip useful. Thank you very much for watching, and I'll see you in the next video.